Hey guys, welcome to the last section of chapter 13. So what we're going to look at here is just some different types of carbohydrates. So we're going to look at the mono, di, and poly. We're going to talk about some that are important or the most important, and then some fun facts about each of them. So from this section is likely where a lot of just the multiple choice conceptual questions will come from this section. So monosaccharides, remember, are just the one saccharide that cannot be broken down into anything simpler. The most important three are going to be glucose, galactose, and fructose. So those are the three most popular and most important to us. The D isomers are all these are found in nature. And again, the D isomers are the ones that our cells recognize and can use and break down. Okay. Just a little bit more about each of these. So glucose is going to be a lot of people call it blood sugar. It's going to be the sugars that are found in our biological systems. Galactose, often called milk sugar. Galactose is one of the components in lactose. So galactose is actually a monosaccharide where lactose is a di. And then fructose is actually the sweetest of all of these. Fructose is a sugar that is found in fruit. And as far as bang for your buck goes, fructose tends to be the sweetest. This is where we get some of those derivatives of the high fructose corn syrup. So they've utilized the fact that fructose gives you the most bang for your buck, and then they've chemically altered it so they could put it in different things. Disaccharides. So disaccharides are when we link two of our monosaccharides together. The big three here that we're going to talk about: maltose, lactose, and sucrose. So those are going to be the three big disaccharides that we learned some fun facts about. Maltose, also known as malt sugar, is composed of 2 D-glucose molecules. So maltose or malt sugar is used in a variety of different things. You'll find it in cereals. You'll find it in some of your candies, dark brown candies. And then it's used in brewing. So you'll find it in some of your beers as well. This is not something you're going to be tested on, but I think it's kind of fun to see some of them. So here's our 2 glucose molecules. So remember that these exist as rings in real life. So here's our 2 glucose. Molecules coming together. And when they link with that oxygen, this is now called maltose. The next one is lactose. So lactose is a disaccharide that has galactose and glucose linked together. Should not be surprising at all where we find lactose. Lactose is found in milk and milk products, dairy products. Lactose is the one sugar that some people have a hard time breaking down. So they have a hard time breaking this link right here, and that can lead to some digestional issues. But this is found in, like I said, in milk and milk products. Then lastly, we've got sucrose. So sucrose is your table sugar. It's obtained from sugar cane or sugar beet. And it is a linkage of glucose and fructose. So with that fructose in there, not surprising that it's very, very sweet. Okay. What we see here is, here's our glucose, here's our fructose. And they're linked together with this oxygen kind of standing up one on top of the other. So with sucrose, we know that sucrose can pose some problems for diabetics. And so we have modified these sucrose compounds to make things like artificial sweeteners, right? So here is a derivative of sucrose, one of the many that we have. This is sucralose. And notice that what we did to fool our bodies is we replaced some of those hydroxyl, those OH groups, we replaced them with chlorines. So here our CET, remember, is typically CH2OH. Oh, well, we replaced that OH with a chlorine. And over here, same thing. Typically, we see a CH2OH. We replaced it with a chlorine. And again, here we have a carbon, and usually it's a hydrogen and a hydroxyl. Oh, but this is a hydrogen and a chlorine. So by replacing some of those hydroxyl groups with a chlorine, it tricks our body. So our body sees this molecule, and it's like, you know what? That tastes sweet. That's going to tell my brain that I just ate something sweet. But then my cells are going to look at it to break it down, and they're going to be like, yeah, I don't know what that is. And so instead of breaking it down and causing that glucose to flood our system, it just sees the molecule and it's like, yeah, don't know what that is. Let me just excrete it right out. The problem is our biological organic systems do not know how to break down sucralose. Well, neither do other biological systems. So if humans can't break it down, guess what else can't break it down? Other plants and other animals can't break down these compounds either. So that's something that we're going to have to start thinking about in the future. The more of these that we use is if nobody in nature can break them down, at some point they're going to start building up, right? So just something to think about with some of these artificial sweeteners. Blood typing. So this is also considered to be in the disaccharide category because the blood types have these different sugars attached to them. So the saccharide, the terminal saccharides here. So just kind of a fun fact. I'm not going to have you memorize any of these blood types. I'm not going to have you memorize any of these things that are attached. This is really just because I can put it in here, so I did. So blood types, you know that there are 4 different blood types. There's A, B, or O. So what differentiates these different blood types is this terminal saccharide. So that we see that with B, blood type B, these terminal saccharides, we've got galactose and then another galactose. So that would be type B. For type A, those people have, for their terminal saccharides, they have galactose. And then they have this green color, which you won't need to know this name, but it's N-acetylgalactoamine. So instead of being carbons and oxygens, there's a nitrogen thrown in there. And then type O actually doesn't have any terminal saccharide at all. So it's got that galactose and then nothing else, okay? So this right here, when they determine what your blood type is, this is what they're testing for right here. What is that terminal, or is there one? Okay. With O not having that terminal saccharide, O is known as the universal donor. So I could put this type of blood into anybody's body and they're going to accept it, right? So type A people are going to see this backbone right here. They're going to say, well, that's missing, but no big deal. I can still use that blood. Same thing with B. They're going to see this backbone right here. And you're going to say, I can still use that. And of course, O, that's what they're used to. AB is the universal recipient. So with the AB, they've got both of these terminal saccharides. So they can see type O and say, oh, that terminal is not there. No big deal. I can still use it. They can recognize the A terminal and say, yep, I've got some of that. They can recognize the B terminal, say, yep, I got some of that. So they can receive any of these blood types. If you are, unfortunately, type A or type B, you can only receive type B or one of these, or type AB. You cannot receive type A. If you receive type A, your body's going to look at this and say, yeah, I don't know what that is with that weird terminal saccharide, and I'm going to destroy it. So if you are a type B and you get type A, that could be a very costly mistake. So that's just the difference in blood types. I put it in here because it has to do with saccharides, or it has to do with carbohydrates. And it's these different types of carbohydrate rings. All right, so the last category is our polysaccharides. So remember, polysaccharides are many monosaccharides linked together. So here we see 4 linked together, but the polysaccharides we're going to talk about have a few more than just 4 linked together. The important polysaccharides that we're going to talk about are starches, glycogen, and cellulose. So we're going to do some fun facts about each of those. So starches, as I alluded to, consist of 250 to 4,000 monosaccharides all bonded together. So these are exponentially long chains of monosaccharides, really, really long chains. Okay. There's 2 types of starches that we're going to talk about. So this first one is going to be this let me get my pointer so you can see where I'm pointing. The first one is going to be this amylose here. What differentiates amylose is it's going to be an unbranched chain. So it's exactly what we see here. It's just going to be one long continuous chain. Now that chain will do some things to kind of conserve space. So to reduce its surface area, it'll do things like coil up. But if you were to stretch it out, what you would see in the end is just one long chain of monosaccharides. The other kind that we're going to see is this amylopectin. So amylopectin is going to be a branched chain. So what you'll see is somewhat of a backbone coming out, and then off of that backbone are going to be branches, like you would see branches on a tree. So it's going to kind of branch out and stretch out in all different directions. So here we see inside of a potato. So potatoes are kind of well known for starches, right? So inside of our potato, we'll see both types of our starches. So we see this amylose here, and as I said before, this is all coiled around just to conserve surface area. But if I were to pull this end and stretch it out, it really just would be one long chain. I can follow it all the way through without picking up my pencil. Okay. Amylopectin is branched. So here we see it coiled around right here, but there's this branch that's coming off, right? I had to pick up my pencil to come back and trace that. And then we see another loop-de-loop right here. And again, another branch coming off here, another branch coming off there, another loop-de-loop, and 2 branches here, another loop-de-loop, and a branch. So amylopectin is a little bit more branched than the amylose. The next starch we're going to talk about is going to be glycogen. So glycogen is going to be stored in our liver and stored in our muscles. So this is how we as animals store energy. When we need it, we hydrolyze. Remember, that was the fancy word for breaking down these polysaccharides. So we're going to break down the polysaccharides. That'll release some glucose, and that'll help us to have some energy. So glycogen is how we maintain our energy level between meals. So we store it, and then when we need that energy, our body will start breaking it down. Very similar to the amylopectin, glycogen is very much a branched polysaccharide, and we'll see a picture of that at the very end in just a minute. Okay. And then the last polysaccharide that we're going to talk about is cellulose. So cellulose is the major structural unit in wood and plants. So it's composed of unbranched, so straight chain glucose. The problem with cellulose is that us as humans cannot digest it. So even though it's a long branched chain of glucose, we like glucose, right? We use that for energy. Our body doesn't know how to break those bonds to access that glucose. So cellulose is one of the major components in fiber. So that's why when we eat a high fiber diet, our body doesn't know how to break it down. So it does a really good job of excreting it, right? So it cannot be digested by humans. Other animals do have the ability to digest cellulose. That's why other animals can use plants and wood that we couldn't use to survive for nutrition. Other animals can digest it and survive on it where we couldn't. So to finish off here, we're just going to look at a picture of the three of these polysaccharide structures. So these first two here are starches. One was straight chain, one was branched. Here's our glycogen, so that's what's stored in our liver and in our muscles. So it's very much a branched polysaccharide. And then here's the cellulose. Something I didn't mention is it is unbranched and it actually stacks together very neatly in these kind of sheets of glucose. And again, that's what gives wood its very structural, very sturdy structure, I should say. So this is cellulose. It's unbranched and it kind of comes together very, very nicely in a sheet. So that is it for chapter 13. That is it for this class. We are done with new material. I hope you guys found these lectures helpful.